We are starting with chapter 12 now, which goes over circles and segments within circles. Our first segment that we're looking at is tangent lines. So a tangent is a line that intersects our circle at exactly one point. So we can see that line AB intersects our circle at only point B. And it's exactly one point. And in this case, it's point B. Things that we can get from our tangent line is that if I look at my circle O, and we'll be able to call our circles based on the center. So if it has a center O, that is circle O. And if we have a tangent AB, so AB, line AB intersects this guy at point P, and we know it is a tangent. Then we know that AB, our line, is perpendicular to our radius through point P. So it's perpendicular to segment OP. And what that means is we're going to get a 90 from the radius that also goes through point P. So we got a perpendicular segment right there. So we're going to use that to find our angle measures. If I look at our first example to find the value of x, ML and MN are tangents. So that means ML and the radius that goes through that are perpendicular. MN is a tangent, so radius that intersects, also 90. In the figure I'm actually working inside of, if we notice, it's got four sides. It's a quadrilateral, and the sum of the angles in a quadrilateral is 360. So if I'm looking for my missing x, I know that I have two 90s. I want to rewrite that. And 117 in my quadrilateral plus x should add up to 360. So if I subtract 180, subtract 117 from 360, I'm gonna get 63. So x is 63. All we're trying to do is, now that we know that something's tangent, there's a 90. So we're going to draw that in. So for ED is tangent to circle O, that means that our 90 is ED and the radius right here, so that's our 90. And the figure we're working in here this time is a triangle. So the sum of the angles in a triangle is 180. So I'm going to add up all those angles. I've got 90 plus 38 plus x, and they should add up to 180. So I subtract 90 and I subtract 38 from 180. And I get 52 for x.